Express cos 4 theta in terms of sine 2 theta, and hence show that cos 4 theta can be expressed in the form of this, where k is a constant to be determined. Hence find the exact value of this. By expressing this in terms of cos 4 theta, find the greatest and least possible values of this here, as theta varies. So that's the question then. So let's have a look at the solution. First of all, cos 4 theta in terms of sine 2 theta. Well, the first thing to do is to write cos 2 theta in terms of sine theta, isn't it? And it would be 1 minus 2 sine squared theta. And that can be easily obtained from the fact that cos 2 theta is equal to cosine squared theta minus sine squared theta. And then just use the trig identities to get 1 minus 2 sine squared theta if you forget. So cosine 4 theta then will equal 1 minus 2 sine squared 2 theta. Now we know sine 2 theta is equal to 2 sine theta cosine theta, isn't it? Put it in here then. 1 minus 2, and then it's 2 sine theta cosine theta squared. So it's 2 sine cos all squared, so that would be 4 sine squared cos squared times 2. 1 minus 8 sine squared theta cosine squared theta. That's what we've got there. Because it was 2 sine theta cos theta times by 2 sine theta cos theta. So we'll end up with 2 times 2 times 2. Sine times sine, cos times cos, 1 minus. So k is equal to 8 in this problem. So hence find the exact value of this. Okay, so theta, so part 2, theta equals 1 over 24 pi gives 1 minus 8 sine squared 1 over 24 pi cos squared 1 over 24 pi is equal to cos 4 of these. 4 over 24 is pi over 6. Pi over 6 is 30 degrees. Cos 30 is root 3 over 2, isn't it? I think it's the exact value we need, yes, the exact value. So we keep it in third form. So here, that tells us then, so sine squared 1 over 24 pi, I'm going to do it in one fell swoop, cos squared 1 over 24 pi, because it's a lot to write, these things, is equal to, so imagine that being moved over there, move the 1 minus root, leave the 1 as is, move the 1 root 3 over 2 over to minus root 3 over 2. So we moved that over there. We move the 8 sine squared cos squared over here. So there's an 8 in our mind's eye here, and divide by 8, which is equal to 2 minus root 3 over 16. Times the top and bottom by a factor of 2, isn't it, to get this. 2 minus root 3 over 16 is the exact value of this thing here, which is what we were asked to calculate. By expressing 2 cos squared this minus 8/3 of this in terms of cos 4 theta. Okay, so divide by 3 and we'll be able to get cos 4 theta, won't we, for this one? And this one shouldn't be too bad as well. So part 3. Here, the answer, save us writing all out. Let's see what we've got then. 2 cos squared 2 theta. Now cos squared 2 theta, 2 cos squared. Well, that's handy, because we know the identity that cos of 2 theta is equal to 2 cosine squared theta minus 1. We know that trig identity. So if we go back up here, we've got 2 cos squared 2 theta here. So 2 cos squared 2 theta will be cos 4 theta plus 1 if we put 2 theta in for theta. So it's cos 4 theta plus 1 is the first term. The second term is minus 8/3. We've got minus 8 here already. So divide by 3 this and move the 1 over. So because 4 theta over 3, and then move the 1 over. Remember we move this 1 over, minus 1 over 3 then, isn't it, if we divide by 3. And that gives us our minus 8/3 of that. So we can put it here. So that's what we've got then. So that's equal to cos 4 theta 4/3 cosine 4 theta. And 1 minus a third is 2/3. So that's what we've got for that. Greatest and least values. When we say the answer, we mean just the trig equation trig values we will find the value. So maximum and minimum and minimum values if theta varies. Well, as theta varies, this will go from 1 to minus 1, so the biggest value will be when it's 1. 4/3 plus 2/3 is 6/3, so that's 2. This will go down to minus 1, so minus 4/3 plus 2/3 is minus 2/3. So there's our maximum and minimum values. Let's just check we finished the question. Yeah, greatest and least values.